What is the slope of a line passing through these points? So whenever we're asked for slope, our slope formula, m, is y2 minus y1 over x2 minus x1. Okay, where any of these points are x1, y1, x2, y2. So for the numerator, we're just subtracting the y's, negative 3 minus 5. For the denominator, we're just subtracting the x's, 5 minus negative 7. Okay, we can do both parts separately, or we can enter it exactly this way on the calculator. Now, to get this horizontal fraction line on your calculator, you're going to press alpha, y equals enter. Again, that was the alphabet button, alpha, the y equals enter. That's what gets you this horizontal fraction line. Now on the top we could do negative 3 minus 5. Go down to the bottom and we could do 5 minus negative 7. You got to be very careful. There's a big difference between minus and negative. Anyway, when we do it this way, the calculator reduces the fraction for us. So if we would have done this ourselves, we would have gotten negative 8 over 12, and we would have to reduce it. If you do it this way on the calculator, it automatically expresses it in simplest form. Okay, and of course that makes our answer choice 2. Okay, number 2. What's the slope of a line passing through the points A and B as shown on the graph below? So in this case, we could get the coordinates of A, the coordinates of B, and use the formula, but there's no need. Slope is also rise over run. In this case, we have a line with a negative slope. It's not really rising, it's really going down. Down 2, across 1, 2, 3, 4, 5, 6, down 2, across 6. Negative 2 over 6 is negative 1/3. If you wanted, on the calculator, we could put negative 2 divided by 6. And then the way to turn a decimal to a fraction is math, enter, enter. So math, enter, enter will give it to us in simplified form. Okay, number 3. What is the slope of the line represented by this equation? Okay, so when we need slope and we're given an equation, we're thinking in terms of y equals mx plus b, where m is our slope that we're looking for and b is the y-intercept. So the y is already in the right place. It's the 4x that has to move, and when it does, on the opposite side, it becomes negative 4x. The 7, which was positive, stays positive, and we're forcing it into mx plus b form. To get y completely alone, we divide by 3 everywhere, and we would see that our slope is negative 4 over 3. Y-intercept is 7/3, but we weren't asked for that. We were just asked for the slope. The cost of belonging to a gym could be modeled by this function, C of m equals 50m plus 7950, where C of m is the total cost for m months of membership. State the meaning of the slope and y-intercept of this function with respect to the costs associated with the gym membership. So this is one of those in the context of the problem things. Normally we use y equals mx plus b. What's weird about this problem is that the x and the y are called m and c of m. So this is sort of like y equals 50x plus 7950, and it's just confusing because m is also usually slope. So our slope, the thing attached to the variable, is 50. What does it mean that the slope is 50 in this problem? Well, if we're talking about a gym membership and the 50 is attached to the number of months, then it means we're paying $50 per month, right? That's your rate of change. That's how much it changes as the number of months change, right? That's how much your total cost will change as the number of months change. This 7950, our y-intercept of 7950 means Well, that's not attached to a variable. That's going to be a one-time fee, right? So there's a one-time fee or an initial fee of $79.50, and that's how you would answer in the context of this problem. Each day, Tony records the height of a plant for her science labs. Her data are shown in the table below, and we want to write an equation. So, of course, we could see that there seems to be an increase of 1.5, making 1.5 our rate of change. And then we can also see, we can figure it out using y equals mx plus b. If 1.5 is our rate of change, what else needs to be added in order to be able to go from input to output, in each case on the table? We're not really going to be doing it like that. We're going to be doing stat edit, stat calc, and let the calculator give us the linear equation. Okay, so stat edit. If you remember, we go up to L1, press clear. It doesn't look like it did anything, but when it comes down, it's clear. Do that again for L2, and we're going to enter our data. In L1 and in L2. Okay, once it's in there, we go back to stat again, but this time we do calc, and we pick item number 4, lin reg. Keep hitting enter till it calculates, and it gives us our equation in the form ax plus b, where a is 1.5, which we knew, we said the slope was 1.5, but b is also 1.5, right? Which would make sense if we tried it out. 1 times 1.5 plus 1.5 is 3. 2 times 1.5, which is 3, plus 1.5 is 4.5, and this would work throughout all the points of the table. Which function has the same y-intercept as the graph below? So let's just be clear that the graph below has a y-intercept of -3. We're looking for any of these to have a b of -3. If I look right away at this first one, I see 3, the number by itself, right? Y equals mx plus b. B is the number alone, not attached to x. That's going to be +3, not -3. For all of the others, we really need to be careful to go get y by itself. We could do it for each one. I'll do it for number 2, for example. The 27 is on the wrong side. When I move it over, 3y equals 6x, and when we move something, we change its sign, -27. When we go ahead and divide by 3, you're going to see the y-intercept, the number by itself, is -9, not -3. No good. Let's jump down to number 4. In number 4, if I want y by itself, it's the 3 that has to move. When it moves, this is my equation. It becomes -3. Doesn't it have that same y-intercept of -3? And that's why 4 is our answer. It has the same y-intercept because it has a y-intercept of -3. The cost of airing a commercial on TV is modeled by this function, where n is the number of times the commercial is aired. Okay, if n is the number of times it's aired, then it depends, depending on how many times it's aired, that's how many times you're paying 110. So 110 has to be the cost per number of times you air the commercial. That 900, well, that's a one-time fee. So if we look through the choices, the 900 being the one-time fee, well, that's how much it costs to put this commercial together. That's a one-time fee. Once it's together, you don't pay that $900 again. What you do pay is $110 each time it's aired. And I know that because the 110 is attached to the variable. Okay, taking a look at number 8. Is it linear or exponential? So we've seen this question before. You can answer it simply by saying, look, we keep going down by 2.5. If I see a constant rate of change, then I know it must be linear. The other way, of course, to do it is stat edit, stat calc. So our first move is always to enter the data. First in L1, oops. And in L2, once we have that data in, now we're going to calculate two different things. LinReg versus Exreg, exponential. Okay, so we go to stat, calc, and 4 is LinReg. We're going to see that when we do LinReg, our R is -1. When you get an R, a correlation coefficient of 1 or -1, it is a linear function, and you need to write that R of -1 tells you it is a linear function, and the equation is -1.25x plus 6.25. You can explain your answer by saying I did it on the calculator and see a correlation coefficient of -1, or you could explain your answer by plugging in inputs and showing that you get the appropriate output in your equation. If we try exponential, stat, calc, 0 for exponential, you're going to see we get an error. So it's certainly not exponential, and you can explain that as well. The graph was created by an employee at a gas station. Which statement could be justified using this graph? So whenever you're asked questions like that, you need to examine each of these specifically. We see that our graph starts at 0, and if we want to see how much it changed, we can use any 2 points and find the rate of change, or the slope. I wouldn't use this one because it doesn't hit at an exact point, but we can use this one. The coordinates here are 4 and 15. So we're basically finding the slope between 4 and 15 and 0, 0. Slope is always y2 minus y1 over x2 minus x1. Subtract the y's, 15 minus 0 on top. Subtract the x's, 4 minus 0 on bottom. And 15 divided by 4 is 375, which tells us the rate of change each gallon was 375. If you go through the other choices, they are not true. Write an equation that passes through these 2 points. There are many ways to do it. The way we're going to do it is on the calculator. Each point is giving us an x and matching y, an x and matching y. So in L1, we're going to put 5 and -5. And then in L2, we're going to put 4 matching to it and 0. Stat calc, we choose 4. And it gives us the linear equation. So again, stat edit, stat calc, lin reg whenever you need a linear equation. And our equation is y equals 0.4, that's what a is, times x. A is what's attached to x, plus 2. We know it's a perfect linear equation again because r, the correlation coefficient, is 1.